Okay, so multiplying and dividing, I don't think, do I have more on this slide? No. Okay, to multiply or divide numbers in scientific notation, so it's still really important. We talked about this last time, and we saw this especially on the homework when you started to do it. You need to check what operation you're doing. So is it a plus sign in the middle? Is it a minus sign? And now, is it a multiplication or division sign? So that you are doing the right operation and following the right steps to get to the answers. So here's our steps. To multiply or divide, powers of 10 do not have to be the same in order to multiply or divide in scientific notation. So you don't have to do any pre-work in order to start your operations. Yes?
Will we add them together as exponents?
It depends. It depends. Yep. But that's going to go back to our exponent rules. So we're going to multiply or divide the factors, which are the numbers that come in front of your power of tens, right? So the first factor times the second factor, bless you. Or the first factor divided by the second factor. All right, so then the last step is going to be multiplying or dividing the powers of 10. And this means we will use exponent rules for when we multiply or divide the same bases. If we multiply two powers, for example, that have the same base, what do we do with the exponents? Add. So that would be the same thing, if we had powers of 10. So if, we're multiplying 10 to the second times 10 to the 8th, they have the same base, we add the exponents. Okay, so that's for multiplication. That's if we are doing multiply in scientific notation.
Why would it ever be like that? That's not scientific notation.
Well, just because first we multiply the powers, and then multiply the factors, and then we multiply the powers of 10. I'll show you.
Oh, so you're going to get a number like...
So you'll get like 2.7.
So you write it in standard form, right? Wait.
You could, but I'll show you. Okay, with division, remember this. If we have same base, and we're dividing, what do we do with the exponents? Subtract. Okay? Same thing with powers of 10, which is what we'll be working with in scientific notation. So if we have like 10 to the 10th divided by 10 to the second, they have the same base. We subtract the exponents. Okay? Let's do some to practice. Okay, and then of course this is the same as last time. Always make sure your final answer is in scientific notation. So when you do your division or multiplication and you get a number in front, remember it has to be between 1 and 10. Okay? Did I skip 4? Yep. Just it's an imaginary step. Let's make that 4. Step 4, make sure your answer is in scientific notation. For example, all right, we are multiplying two numbers in scientific notation. So remember, we're always going to check the operation so that we do the right thing. All right, so here's what we do. First, multiply the factors, because when we're multiplying, we don't need to get the exponents the same. We can just start multiplying. First, multiply your factors. 3 times 5.
15.
3 times 5 is 15. Okay, and then we're going to multiply our powers of 10. So 10 to the negative 5th times 10 to the negative 2nd. So this is what I was talking about. We've got the same base, and we're multiplying. What should we do with those exponents? Add them.
So 10 to the negative 7.
Exactly. So 15 times 10 to the negative 7th is what we get when we do the multiplication. And then our last step is, of course, to get this in scientific notation, our final answer, Is it in scientific notation right now? No. We have to move this decimal so that we get 1.5. We moved our decimal to the left. What do we need to do with our exponent? Add 1. So we get 1.5 times 10 to the negative 6. All right, Malia, tell me what you did.
So you do 7 times 3 and you
Good.
get 21.
Good.
And then times 10 to 7.
Good, because you added the exponent. So 21 times 10 to the 7th. Good. Then what did you do?
Then you have to move the decimal to the left.
Good.
So you add 1 to the exponent.
Perfect.
You get 2.1 times 10 to the 8.
Perfect. 2.1 times 10 to the 8th. Tell me what you did.
6 times 2 is
Good.
12.
Yep.
And that's times 10 to the negative third.
Good.
And then I made a 1.2 times 10 to the negative second.
Perfect. Okay. First we multiplied the factors. Then we multiplied the powers of 10, added their exponents, and then got it into proper scientific notation. 1.2 times 10 to the negative second. Very good. All right, let's see if we get to division here. Let's try this one. Remember this from yesterday?
6 times 2.
Notice that our first expression, I guess we would say, is not in scientific notation.
A number there.
Now, with multiplication, you can either turn this into scientific notation, or you could actually just do your multiplication of the factors. But I think it's helpful to turn it into scientific notation just so you can see what you're doing. 6 times 10 to the what? What did we say?
0.
Yeah, 10 to the 0. Okay? 6 times 10 to the 0 times 8 times 10 to the negative 5th. Okay, so when we multiply our factors, we get 48. Okay, and then combine the exponents, 0 minus 5, or 0 plus a negative 5. Stays negative 5. This is not in scientific notation, so we move the decimal to the left and add 1. Negative.
Times 10 to the negative 4.
Perfect. Written vertically. Okay, yes. Segan.
So do you do all the stuff on top and bottom, and then do you subtract the exponents from each other because it's going to be divided?
So what I would do is this. Divide. 1.5 divided by 6. So divide the factors. So 1.5, let's see, divided by 6 is 0.25. And then deal with your exponents. These are the same base. We're dividing, so we'll do negative 8 minus 7. So it's going to be to the power of negative 15. So times 10 to the negative 15th.
I move it to the right.
Yep, and then we've got to move it to the right, which means we subtract 1.
So that's negative 16.
Very good. 2.5 times 10 to the negative 16th. So you do the same thing. Divide the factors, and then because we're dividing, we have the same base, we subtract the exponents. Good? To try another one? Okay, this one's written horizontally. This is usually how you're going to see them. So always check what is the operation that you're doing. If you multiply, you're going to get a different answer. So don't multiply, make sure you divide. So start by dividing your factors. 1.5 divided by 7.5.
Is that like 3?
I think it's going to be smaller than that. 0.2.
That's a lot smaller.
Mm-hmm. 7.5. Okay. And then with our exponents, we're going to do -3 minus 2, which gives us 10 to the -5th. Okay? Then we have to change this to scientific notation.
Wait, how did you get that? That doesn't make sense.
So we're dividing, right? And when we divide, what do we do with the exponents if the bases are the same?
Subtract.
Subtract. -3 minus 2.
So then wouldn't that be one?
No.
-3 minus 2.
You're going more negative.
Like that. -5. Okay, to move this to scientific notation, we've got to move our decimal to the right. And if we move the decimal to the right, we subtract 1 from our exponent. So 2 times 10 to the -6th. First thing to check is your operation. So we are dividing. Make sure you divide. 3.75 divided by 1.25. 3.75 gives us the whole number 3. Okay? And then we're going to subtract. Be careful. -8 minus a -7.
Is that positive?
So these become positive.
-1.
Yes, 10 to the -1. And then is this in scientific notation?
No, yes.
Yes, so we're done. So be careful with the subtraction. You are always doing the first minus the second. If it's a negative, you're subtracting a negative, which becomes adding. Where we don't have the second term written in scientific notation. So what should this be? Times 10 to the?
0.
Yeah. 10 to the 0. So start by, this is division. 9.2 divided by 4.6 is just 2. And then we'll subtract our exponents. 12 minus 0 is 12. Is this in scientific notation?
Yes.
Yes. So we're done.